In this video, we're going to be setting up a Blazor application that will run inside a Docker container. This video is intended for someone who is brand new to Docker, so if you're not sure if you should be learning Docker, yes, you absolutely should. Or if you've been particularly intimidated by it, then don't worry, I've got you covered. You're going to be amazed how easy it is to get going with Docker. Right, so we're going to be going through what Docker is and what the key concepts are, why you as a developer want to use it, what tooling you need to use, and we'll briefly touch on the installation. Then first we'll use Visual Studio Code to manually create a Docker container that will run a .NET console application. Then once we understand the steps, we'll create a container using Visual Studio, the quick way that will run a Blazor application. All good? Let's get started. So what is Docker? Docker is an open source platform that lets you build, test, and deploy your applications. But more importantly, Docker lets you package up your application into isolated units called containers that have everything you need to run your application. This includes the code and any dependencies your application needs, the runtime, any particular libraries, whatever is required for your application to run. The beauty about this is we get to set and fix the environment so that the application runs the same way every time, regardless of the hardware that it is running on. So why would you want to use it? Well, Docker has a few massive benefits for developers. Docker makes sure your application runs the same way on your local machine as it does on any other hardware setup. This alleviates that age-old excuse of, it runs fine on my machine. Then it simplifies your setup. Docker allows you to define an environment once, so there's no need to install dependencies individually. Running the app becomes as simple as pulling down the container and executing a single command. Then containers run in isolation. This means that you can run multiple versions of your application without them conflicting with each other. Docker containers are easily portable and make sharing very easy. And then this helps with onboarding. New team members can get up and running quickly just by pulling down and running the required containers. They don't need to spend time setting up a complicated environment. So at this point you may be thinking, well, Mark, this sounds exactly like a virtual machine. And yes, you'd be right in the sense that both virtual machines and containers run applications in isolated environments. But there's some differences. Multiple virtual machines running on the same physical machine will each take a slice of the hardware and the resources, each with their own full-blown licensed operating system. On the other hand, containers are lightweight and all share the same operating system and hardware. There are three key concepts that you need to know about when using Docker. First and most crucial is the Dockerfile. This is really just a text file that has instructions on how to create an image. These instructions will include what code to copy and what dependencies to install. Using the docker build command, this Dockerfile will generate an image. An image is just a read-only blueprint for a container. Images are easily shared and can be pushed to or pulled from a registry like Docker Hub. Then finally, a container is an instance of a Docker image. In reality, this is just a running process that can be started, stopped, and restarted as many times as you want from the same image. Now, before we get into the tooling we're going to use for the demo, I want to mention about the image registries. So we can store and share our image with an online registry. The largest and most well-known of these is Docker Hub, is where you can push your own Docker images or pull down already made images. Now we're going to get into the demo and we're going to start by installing Docker Desktop. This lets you view your containers and will give you everything you need to create containers from the command line. For all the basic stuff, Docker Desktop is free. I'm choosing to download the one for Windows. Then you should know that there are two types of containers we can build. There's Windows containers and Linux containers. Which of these you choose will depend on the application that you want to run in your container. If you're a regular on my channel, you are likely only ever going to be using Linux containers. This is because you're writing for .NET Core applications, and .NET Core applications are cross-platform. So when installing Docker Desktop, you may be prompted to update the WSL2 kernel. This is Windows subsystem for Linux, and you just need to do it if you're asked to do it. Right, now that you've got Docker Desktop installed, just make sure that the engine is actually running in your system tray. That's really all the new tools we need, since I'm going to assume you already have Visual Studio Code installed. If you are like me and love collecting extensions for VS Code, then you're probably going to want to install the Docker extension as well. I'll have links for all this stuff in the description below. So now we're going to use VS Code to do the following. We're going to create a Hello World console application. We're going to create a Dockerfile, build the Docker image from the Dockerfile, and run the Docker image, which will create our container. So let's open up the terminal with Control tilde. First, we'll create our console application from the command line, targeting the current version of .NET. Then let's just run it to see if it works. And as expected, here's our hello Docker, you beauty displayed in the console. So next, let's write the Dockerfile. This is the fun bit. So let's create a new file and name this Dockerfile. Just take note of the capital D, and there's no file extension. So our Docker image will be built up of stages or layers. Each stage will perform a different task. We'll have a stage to specify the .NET runtime, a stage to actually copy and build our application within the container, and then a stage for running our application. So we could go and manually install the .NET runtime, seeing as it's one of the major dependencies that we need, but it's way easier for us to go and use one of the pre-existing images that Microsoft provides for us. So we're going to go and take a look on Docker Hub and see what options are out there. If we search for .NET, we find a bunch of Microsoft's official images that are available. There's one for the SDK, there's one for the ASP.NET Core Runtime, there's one for the Aspire dashboard, etc. We're currently interested in the .NET Runtime. If you were doing a web app, you'd probably want the ASP.NET Core. Here we're using a console app, so we just want the runtime. So we're taken to the GitHub page for this image, and we are interested in the address. Now this address points to the Microsoft Artifacts registry. So here we're going to specify from, we're going to specify the address, and we're going to go and give our image and the name of base. We'll specify the working directory and /app. Initially there won't be any directory of that name in the container, but that command will create one if there isn't one, and then change to that working directory. Then for our next stage, we need our SDK, and we need our SDK to be able to build the application. So once again, we're going to go back to Docker Hub and find the address that we need for the official Microsoft SDK. And we're going to specify our new stage with the address for the SDK, and we'll give this stage the name of build. Once again, we'll specify the working directory /app. And now we're going to copy our code from our host machine into the container. The first period represents the working directory on a host machine. The second period represents the working directory or the location in the container where we want the code to be copied. Then we specify the publish command that will run inside the container. This is going to build our application with the release parameter. And now for our last stage, we're going to specify from base, and this will specify the base image for our final stage, and we're going to give it a name of final. Base relates to that first base that we had in our first step. We want base to be our starting point here because we only really need the runtime image to be able to run the application. If we had to use our build stage as our base, well, then we would be bringing all the unnecessary SDK with us. Rather just using base as a starting point, we are only using the runtime. This keeps our final image very small. So then we specify our working directory as /app. And what we're going to do is copy the output from our build stage to our working directory. And we declare our entry point. This specifies the executable and its arguments. And this ensures the application starts immediately when the container is run. Now we can run the docker build command specifying the tag, which is just the name. We'll call it hello docker. The naming convention here is that the docker tags should all be lowercase. Don't be surprised if this takes a bit of time. The images may need to be pulled down from Docker Hub. If you end up with an error here saying that the system cannot find the specified file, this error usually means that your Docker engine isn't running. So you just need to make sure you launch Docker Desktop. Look for the little Docker whale icon in your system tray. So now all that's left is to actually run our Docker container. We use that using the Docker run command, followed by the tag name for the Docker container. And here you can see the output of our hello Docker you beauty, which is the output of our console application that's running. So we can now go and see what's happened in Docker Desktop. If we go and have a look at our containers, you can actually see that we have a Docker container hello Docker console. And likewise, we have an image, hello Docker console. So now that we know how to create a Dockerfile and an image and a container itself the hard way, let's go and see how easy it is to do with Visual Studio. So I have the default Blazor application project here. So in Visual Studio, to get this going with Docker, right click on the project, go to Add, Docker Support. And at this point now it asks us to choose which type of container. Like I mentioned earlier, we want to be using a Linux container because this is a .NET Core application that we want to run in our container. Our build type is going to be Dockerfile. All of the rest you can just leave as default. We're going to go OK. And what it'll do is it creates our Dockerfile, and you'll see what it would have generated, something very similar to the one that we manually did. This one has a bit more detail than what we did. So now we can hit F5 to run the application. You'll notice at the top it actually says run within the container Dockerfile. And here it's mentioned from the output window that it started our container successfully. Visual Studio comes with its own little view of our containers that are available. And here you can see our Blazor application running. Right, so if we stop this and we can go and have a look in Docker Desktop. And here, likewise, you'll see that we now have a container showing Docker with Blazor. So if we have a look at the Dockerfile that Visual Studio has created, it's very similar to the one we made. There's a couple of extra bits. So from our base image, it's using the official Microsoft ASP.NET Core with .NET 9 as the base image. Here we're specifying a user, we're changing the working directory to a .app. Then we're exposing two of the ports inside of the container, 880 and 881. This really lets us access our web application from outside of the container. Then our second stage is to build the project. Once again, we're going to grab the SDK and define that as a build. We're going to set the build configuration argument to release, change the working directory. So here Visual Studio has specified an absolute path for the file to say where we're copying it from our host machine to where it's going to go inside of our container. Then we're going to run the .NET restore to go and get if there's any NuGet packages or anything that needs to be resolved for our project. We then go to copy the code again from the host directory to the current directory inside the container. Change our working directory to the source of the project, and we're going to run the build command with our build configuration variable that we specified here, which is going to be release. Then we're going to do the publish step, very similar, declare it as publish, and we're going to call the release, and we're going to use the build configuration that we specified further up. And then as our final stage, again, we're going to specify or build on top of our base, our initial base stage that we had up here. This is so that we are just using the runtime and we don't need to worry about all the SDK. Once again, this is to keep our final image as light as possible so that we're not building on top of the SDK that we use for the build section. We are just using the base image that really just has the .NET Core runtime. Then we're going to change our working directory. Then we're going to copy the output from our publish stage from the app publish folder to our current working directory, which is /app. And then we're going to declare our entry point of our application, which is calling the .NET command. And we're going to specify our entry point, which is calling the .NET run command with the DLL, which is going to be our application that we're going to run. One thing that's worth noting is you require Visual Studio to be running to run this Docker container. When you eventually need to run your container without Visual Studio, you'll need to build the container from the command line like we did in the previous step. That's why it's good to know. So while this is a great start from Docker, as soon as you destroy one of your containers, any data in there will be lost. So you'll need to know how to persist data from your Dockerized containers. You'll also probably want to know how to set up a database in another container and have your containerized application talking to the database. So you should watch this video up here that tells you how to do that once it's ready.